Okay, we're just going to test the sound now, and we'll be underway at 7. So, yeah, welcome everybody. Yeah. Okay. How's our sound going? I think we're all good. All right. Okay. Yep. We're all good. So I'll turn my sound down here so that it doesn't feedback. All right. Let's get underway. Well, good evening. And this is my 7th episode at maurieo Maths IRL. So the whole intention of this program is that you can drop in with your problems at any time and ask for help. But obviously, I just can't sit here vacantly looking at the screen and not doing anything. So I'm just working through some basic mathematical concepts and ideas. So feel free to interrupt me with whatever maths problem you have. The whole intention of this is that it is live and interactive, so that we can work with your questions and make sure that you're understanding and improve people's understanding. So the minimum time that I stay online is half an hour, but if someone was to come online, I wouldn't stop in the middle of something. So yeah, all right. So last time I asked, last night I was on, and I suggested that we should draw the graph of y equals x plus 2 using a table of values. So we're going to draw that graph. Table of values. So normally we would draw 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5. These are negative. Okay, so these are the x values. Okay, so that's table of values there. And then here we have x plus 2, so just 7, 6, 5, 4, 3, 2, 1, 0, table of values there. Negative 1, negative 2, negative 3. And so these give us our ordered pairs on our Cartesian plane. We'll try and draw it in here like this. 0 might be a bit tricky. 1, 2, 3, 4, 5. Negative 1, 2, 3, 4, 5. So you can see that's our x values there. And then here we go 1, 2, 3, 4, 5, 6, and I'll go up to 7. And then here negative 1, negative 2, negative 3. So that's negative 3. You can see that's x 0. Values there. That's 5 there. We'll make that negative 5, and we'll make this 5. So whenever we're asked to draw any graph, really, we can always draw it with ordered pairs, or we could use something. There's various online programs as well that we could use. So then we just start plotting them. So 5, 7 is there, and then we'll go 4, with ordered pairs. 6, or we could use 3, the various online 3 programs as 5 that we could use. So then we just start putting them. So 2 is 4, I think. 2, 4, yep. And we'll go there. And 1, 3, and 0, 2. Now, we said that this here is your y-intercept. Here, and you can see that there it's at plus 2. Then we're going to have, so that was 0, 2, negative 1, 1. This here is your y-intercept. 0, 0, 2, negative 1 here. And you can see that 1 is there. Got that wrong. Then we're going to get rid of this one. So that was 0, 2. Hold the button on with this. Right, negative 1, 1, and negative 2, 0. 0, 2. Here like this. Negative 2, 0, and then negative. Going to get rid of this one. Negative 3, negative 1, which is here. Negative 4, negative 2, and negative 5, negative 3. And we can see that those all negative 3 quite neatly fit on the line, and if we were to plot them accurately on gridded paper and things like that, of course we would see that that was indeed the case. So from this, there's a number of things come out of here. I think first thing was, so this here is what I would say draw or plot. And things like that. Draw. Of course, we would see that or plot is indeed the case. And typically we'd do this on gridded paper, and we'd do it to, you know, a scale. There like that. Now, if I was to say, let's say I would say to do a sketch. When we do a sketch, we just go like. We draw our Cartesian things, and we show the key points. Now, one of the key points is the y-intercept, which was there, and we would know that that is 2. So we know that point there. And here we can see that our x value, remember that our standard form is y equals mx plus 2. So this m here is the slope. And in this case here, x is on its own, so the slope is 1, and it's positive. So standard form y equals mx. It's positive. So it's we know that that's been the case, that that'll be negative 2. Okay. So the other points that we can determine like that, because remember slope. Well, positive slope. So it's equals delta y over delta x. Now delta y is the rise. Like that, because remember that's how much it's going up, and delta x is what we call the run. Equals. So in this case here, over 1, we could say, if we go 2 rise, it's we can work out the rise over here. The rise is 2, and the run is 2. It's going from left to right, therefore it's a positive graph. So that's y equals mx. Rise it's
carried away there.
We can work out the rise.
Y equals
The rise is 2 and
x
the run
plus
is 2.
2.
It's going from left to right, therefore
Okay,
it's positive.
so that's the name of that graph.
Y
Now,
equals
there are other things that we can see. This here is the x-axis, and this is the y-axis. Now, if we look at y equals mx plus 2, now let's say we have a line that has no slope. Axis, and this is the y-axis. 0 slope. Now, which is possible. So we're going to get y equals 0 mx x plus 2. Now, let's say we plus have 2, a line that has and no then we get slope. Y equals 2. 0 slope. So the y value is 2, and it doesn't matter what value of x. If we put this line in here, that is a straight line. It's parallel to the x-axis, and its value is y equals 2. So the y value is 2, and it doesn't matter what value. And if we had a line in here, a value, a straight line, it's parallel to the x-axis, and its where y equals y is 0. So if we said, well, like y equals 0 into this formula, if we said 0 equals mx, where y is plus 2. And in our case here it's equal to y equals 1 into this formula. If we said 0, so we can just take that out. We get x equals negative 2, and x equals negative 2 is that line there. And in our case here it's equal to y equals 1. Okay, so that just there. So take that out. When we're sketching things, there's a couple of very useful little tools that we can use. So say for instance, let's just go back a little bit, and let's say the question was, let's just say that the question was, little tools that we can use. Sketch. So for instance, let's just the graph back a little bit, and let's say the question was y equals x plus 2. Say that the question now, was. Now, if we draw our Cartesian plane like this, this is our x-axis, and this is the graph y-axis, and y equals x. We can see that they are straight lines. If we draw, so they too will have an equation. And so what is the equation of the x-axis? Well, its equation is y equals 0. Everywhere along that line, y is 0. And similarly, the y-axis is the line, x equals 0. Y equals 0. So, one of the tools that we can do, and I always write it, and similarly, when x equals 0, the y-axis is the line when x equals 0. Okay, so we can investigate what happens on that line, on this line, when x equals 0. That will give us the y-intercept, and we can see there when x equals 0, y equals 0 plus 2 equals 2. So then we can say, oh well, for that graph,
equals 0. That will give us the y-intercept, and we can see there when x
that's a point on the graph. And working with 0 is a lot easier because it eliminates a lot of things. And then we can say, okay,
so then we can,
when y equals 0, and this is only in the case of y equals x plus 2, or whatever graph we're working with. When y equals 0, we can say 0 equals x plus 2. And then we can say, right, x equals
x plus 2,
negative 2.
We're working with when y equals 0,
and
we can say 0
we can
equals
put in the point
plus 2,
negative 2. And from down here we can see that if we go rise, like we did above there, rise, and 2, rise over run is, even though we're going there, that's going up, which is positive, and across left to right, which is positive. So we know that m is equal to 1, and so we can draw or sketch our graph in, and we can say that's y equals x plus 2, which is positive. And across left to right. And so equally, we can look at just the graph and determine the equation. So we need to practice some of those. So let's we'll have a look at a different, something slightly different here. Well, we'll just have one more sort of example that shows us a few things. So let's do a table of values here. Let's say x. We'll do it in. Let's say x in here.
One more sort of example,
and let's go
a few things.
5, 4, 3, 2, 1, 0, negative 1.
Let's say x,
negative 2, negative 3, negative 4, negative 5. And then in here, let's go y equals x. And there we'll just get 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5. So if we were to draw that,
y equals x
here,
and there we'll just get
1, 2, 3, 4, 5,
negative
1, 2, 3, 4, 5, 1, 2, 3,
so if we were to draw
5,
that,
6, 7, 8, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, 8, negative 9, 3, we'll get one more up here. Okay, so if we did y equals x, we can just say 0, 0 is there, and you can see it'll be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And you can see what's happening there.
we can just say
2,
0, 0
3,
is there, and you can see it'll be 1, 1,
5. We can get a straight line.
4, 4,
Y equals x.
5, 5. And you can see what's happening.
And I think can probably work out that it would be at 45 degrees there. So what happens if y equals 2x?
4, 4,
Y equals x.
5, 5.
well, we'd just go 10,
I think can probably
8,
work out that it would be
6,
45.
4, 2,
45
0,
degrees.
negative 2, negative 4,
what
negative
happens if
6,
y
negative
equals
8,
2x?
negative 10.
Y equals x.
And the thing is,
Just go
I'm going to ask the question, is it going to be
6, 45, 4,
steeper or flatter?
negative
Okay, well, it's going to be 1, 2,
negative 10.
2, 4,
And the thing
3,
is, I'm going to ask the question,
6,
going to be
4, 8,
steeper or flatter?
1,
Okay.
negative 1, negative 2,
It's going to be 1, 2,
negative there,
negative 10.
2,
And
oh,
the thing
3, negative 1, negative 2,
6,
oh, negative 2, negative 4, negative 3,
or flatter?
1, negative 6,
Negative 1,
and 5, oh, 4, sort of 8.
2,
So we can see there that that's the graph, negative 1, negative 2,
6,
oh, negative 2. That's the graph of y equals negative 6, 2x. So that means it's going to get steeper,
sort of 8.
steeper and steeper like that, like steeper. So what about y equals half x?
2x. So that means it's going to
Okay, so that's 5 is going to be 2.5, 4 is going to be 2, 3 is going to be 1.5, 2 is going to be 1, 1 is going to be 0.5, and 0 is going to be there. And then down here you'll see that these will be reflected in the thing. So we can go negative 0.5, negative 1, negative 1.5, negative, what do we got there? Oh, negative 2, negative 2.5. Okay, so the half ones would be 1 and a, we'll do that in red.
negative 1,
1 and a half. Oops, no, we're doing it in red.
negative.
No, still no.
What do we got?
There we go.
Negative 2,
1 and a half, 2,
negative 2.5.
2, 1.
Okay, so the
So
half
it's like that.
1,
4,
we'll
2,
do that in red.
and 5, 2 and a half, and 1 and a half.
No, still no.
No, 2 would be 1, 3 would be 1 and a half, 4 would be like 2.
2, 1.
And
Such like that.
we can see that that one
2,
is going to give us
and 5, 2 and a half.
and
a
a flatter curve. That's going to be y equals a half.
4 would be 2.
Now, let's
We can see.
see what happens
Going to give us
if we go, for instance, we look at
it's going to be
y equals negative x. So that's just going to go negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3,
for instance
4, 5. And what you'll see there is you'll go 1,
equals negative x.
negative 1,
So
2,
it's just going to go negative 5,
negative 2, 3, negative 3, 4, negative 4, 5, negative 5.
1,
Negative 1 will be 1, negative 2 will be 2,
5.
negative 3 will be 3, negative 4, and like so. And so
Just going to go negative
we get this graph down here, which is y equals negative x.
negative 1 will be 1.
Okay, and it's at right angles to y equals x. If I draw it correctly. There. So, and then we can see that if we say, let's just take y equals x, well, we did that earlier. We come back up here, we look at y equals x. Here's y equals x here. So, through there, y equals x. We can see that if we say, let's just now it has the same gradient. Remember the m, y equals mx plus c. Remember the m tells us the gradient, it's 1, y equals x. And then if we add 2, it just moves the whole graph up. Right, y equals x moves it up like that, and then we can change the gradient. So pretty much we can move and generate these straight line graphs. So what we want to be able to do is to get to the point where we can draw or sketch straight line graphs. So let's say let's sketch, generate these straight line graphs. Let's sketch y equals we can draw or sketch straight line graphs plus 5. We'll do that. So I'll do that here. Y equals x plus 5, there like that. I know the y-intercept's going to be 5. That's equals when y equals, the y-intercept will give me 5. When x equals 0 will give me the y-intercept. When x equals 0, we can say y equals 5. Okay, so that's cool. Do that. And then we can say when x when y equals 0, x equals negative 5. Do that very quickly there. Okay, and then that's cool. Do that. So that's our graph, y equals x plus 5. Okay, let's look at x equals negative 5. Sketch y equals, and then that's 3x. So that's plus 6. Y equals 3x plus 6. Right. So look at we do this here. We can see our y-intercept is 6, so it's going to go through 6. Now we could say 3x. When x equals 0, we can see that y equals 6. We do this here. Now, when we can see our y-intercept is 6, when y equals 0, now we could say 3x plus 6 equals 0. Well, y equals 6. Take 6 off both sides. 3x equals negative 6. I left a bit of a step out there. We can divide by 3. Plus 6 equals 0. And we get x equals negative 2. 3x equals, so there's negative 2 there. Here's our bit of step out there. We can divide by graph. Plus 6 equals, always label them. Y equals 3x plus 6 equals. Okay, rise over run 2. The rise is 6 over the run 2. 6 over 2 is 3. That's good. Y-intercept is 6. Yeah, so that's that one there. Now let's try. Let's have a look at sketch. 2. The rise is 6 over the run 2. 6 over 2 y is 3. That's good. Equals negative 2x minus 4. Y equals negative 2x minus 4. And, well, let's have a look at that. So, well, it's in the form y equals mx plus c. So we know that our y-intercept's going to be -4. We can just check for that when x equals 0. That will become 0, and we get y equals -4. Now that's pretty easy. Now I'm writing this down. I always check out when x equals 0, because this is a valuable tool that applies to all graphs. Not all graphs are straight lines. So it's a very useful tool, and it's a very good habit to get into. So that's cool. Now let's have a look at when y equals 0. Check out when x equals 0, because this is a okay. When y equals 0, we get 0 equals -2x minus 4. So let's when y equals, I've run out of room over there, so I'm going to add 4 to both sides. 4 equals, which will eliminate that 4, -4 plus 4 equals -2x. Then I'm going to divide by -2. So let's we get -2, and we get x equals -2. Okay, x equals -2, so that's it there. -2, and here's our graph down here. Y equals -2x minus 4. So there's our y-intercept there. Okay, x equals, that's our y-intercept there. And -4, and we can see that our rise is, if we come from here, our rise is -4. So there's our y-intercept there. It's a depression, but -4, and that's the run is 2, -4 over 2, -2. So our gradient's correct. So that's the graph there of y equals -2x minus 4. All right. Let's just think about this for a moment. We can pretty much draw any straight line now. We've pretty much looked at all of them. So time to wind it up for tonight here. So let's have something. Now, not always do the graphs come in the form y equals mx plus c. There's other forms of the linear equation. So we could we could have like 4y plus c. There's other forms of the linear equation. So we could 3x. We could have 4y plus 3x. So let's say y plus 4y plus 3x equals 20. That will be a 4y plus that will be a straight line. However, it's not in the form y equals mx plus c. So we'll just put that here to write the question here in readiness for tomorrow night. So sketch, that will be a straight line, the graph. However, it's not in the form y equals mx plus c. So 4y, we'll just put that here plus 3x in readiness equals 20. So that will be the graph by rearranging 4y, it's 3x into 20, y equals mx plus c form by rearranging before sketching. So what we need to do with that one there is put it in the form y equals mx plus c. How are we going to do that? And then we need to sketch the graph. So that's going to be it. That's going to be the takeaway, and we'll have a look at that. So, you know, if you're following through this and you want to have a look at, or, you know, try something on your own, see if you can do it, well, that's one to have a go at. So that's all for tonight. Remember, you can contact me at any time in the comments or anything like that, and if you want examples, you know, me to work through a particular example or cover a particular topic. The value of the maurieo Maths IRL is that it's live, and so that you can interact and you know, do things here and you know, ask questions and get, you know, some full learning concepts. It doesn't have to be the concepts I'm dealing with. You can talk about anything. If you want to talk about prime numbers or order of operations or Pythagoras, any of those things, I'm happy to do that. All good. Okay. All right. Well, good night and good gardening to you all. This has been a maurieo presentation. It's recorded live in our lovely little studio in downtown Ngaruawahia, the Big Smoke in Aotearoa, New Zealand, a place where Kiwis live in a paradise we like to call God's own country. Good night and good gardening.